Welcome to Ask and Learn.
Hello everyone. In this problem, a series parallel combination of RLC circuit is given which have a voltage magnitude, a voltage source which have magnitude of 6 cos of 200t, and the element are connected in the following manner: a resistance of 5 ohm, a resistance of 5 ohm, and again the parallel branch which have a resistance of 4 ohm, inductor, (10 millihenry), and a capacitor of 5 millifarad, and a resistance of 3 ohm is connected in this way. And we have to find out the value of I of t. We will find out the value of I of t, which is the total current in the following circuit. Okay. Now, first, for finding the value of current in this circuit, we have applied simply the formula I equals to V upon Z, where V is the input voltage, which is the magnitude of 6 volt at the frequency of omega equals to 200, right? And Z is the total impedance of the circuit, which is the overall calculated by the series parallel combination of these elements. Okay. Now first we have to convert our inductance and capacitance in the reactive form. Okay. We have to convert our inductor and capacitor in the reactive form. Then we have simply calculate the total impedance of the system, which is the Z, and here the volume of voltage is V, and by dividing simply V upon Z, we can find out the value of current I of t. Okay. So now first we have to convert our 10 millihenry inductor into reactive form, which is the J omega L, or we can say that XL. Then the value of inductor in reactive form will be J omega will be 200 and L will be 10. Then XL or J omega L will be iota 2, because this is in millihenry, so we can simply multiply by 10 to the power minus 3. Okay. Now same as we have to calculate the value of capacitor. This is 5 millifarad. So capacitor, for capacitor 5 millifarad, it is converted by simply 1 upon J omega C. Now 1 upon J 200 omega C for 5 into 10 to the power minus 3. Then this is given minus iota. This is the XC, or 1 upon J omega C, right? So now first we have to calculate the total impedance of the system. Here there are three parallel branches. Right? The first branch which have the value of, assume Z1, this is the value of Z2, and assume this is the value of Z3, which have value of 3 ohm resistor and 5 millifarad capacitor, right? And there are another resistance of 5 ohm. So there are different method for solving this problem, right? So first we have to calculate the value of Z. Then first we calculate the impedance of each branch, Z1, Z2, Z3, or we can simply calculate the admittance of the system. Why? We have calculated the admittance of the system. Why? So if we are using the formula admittance, then the total Y will be given Y1 plus Y2 plus Y3 for these three branches, right? Then Y equals to 1 upon Z1 plus 1 upon Z2 plus 1 upon Z3. Okay. So now putting the value of Z1, Z2, Z3, Y equals to Z1 is 4. Z1 is 4. It is 1 by 4 plus Z2 1 upon, there are 10 millihenry inductor, then the value of 10 millihenry is iota 2. So we put here 1 upon iota 2, and again the branch which have series combination of capacitor and resistance, the value of Z3, it is give 3 minus iota. Okay. Now by simply solving this equation, total admittance of the system will be 0.55 minus iota 0.4. It is calculated by simpling. This is 0.25 minus iota 0.5 by transferring this function into numerator form, and 1 upon 2 0.5, and by cross multiplying this value with the opposite complex quantity, right? So it give Y equals to 0.55 plus iota 0.4. Okay. So now we calculate impedance Z. Z equals to 1 upon Y equals to 1 upon 0.55 minus iota 0.4. By solving this value, the impedance of system will be 1.1892 plus iota 0.865. This is the impedance of three branches. Now we have to calculate total impedance ZTH, which will be Z plus 5 ohm resistance, which is connected in the across the voltage source. Okay. So now 1.1892 plus iota 0.865 plus 5. Now this is ZTH, which have a value of 6.1892 plus iota 0.865. Now calculate the value of I of t. Now I of t equals to V upon Z. Now what about the V? 6 angle of 0 degree upon 6.1892 plus iota 0.865. Okay. Now by solving this equation, the value of current I of t equals to 0.96 angle of minus 7.956. Okay. Now written in the time domain, it will be I of t equals to 0.96 magnitude cos factor as compared to input voltage source, cos factor 200t minus 7.956. Okay. So in this problem, what we have do, this problem, what we have to, a simply series parallel combination of a circuit is given and find the value of input current, total current I of t. So first we have to convert our inductor capacitor in the reactive form. Then we have calculate simply total impedance of the circuit Z by applying the simply impedance method and put the formula I equals to V upon Z and the calculate of the value in the form of time domain, which have the value of 0.96 angle of minus 7.956. Thank you.